Hello, sorry I'm late. Core meeting went a little over.
Morning, Mark.
Good morning, Casey. All right. We don't have too much on the agenda for today, but should we get started?
Yeah.
Sage,
With the pull
before
requests.
before I forget, David was just asking about changing the debug level of the of trim in Blue Store to like something higher than 20 because it's so
Go
noisy.
for it. Yeah, it's super
That's kind of what I
noisy.
was thinking.
Yep. Yep. It was good when it
Either,
was buggy, but it's not buggy. So let's turn it way up.
yeah.
Yep.
Um, Alternatively, we could actually put the whole trim piece in like a separate debug thing too, if we wanted to, just to like completely get it.
Yeah, I'm not sure that that buys us much. It's the only thing
Okay.
really at a higher debug level. So either you turn on the new channel or you turn up the existing channel. It's probably the same thing.
Okay.
But yeah, let's turn it
Cool.
up
Sounds good.
or down or whatever. Yeah. Yep. Cool. Okay, so there's a pull request that suggests disabling the op tracker. I think they showed like a 20 or 30% performance improvement. What was it on small IO?
Yep.
It's a big
It
big
was.
difference.
So I actually started looking at that this morning because I've got really recent wall clock profiles, and
Yeah,
a lot of it is like destroying strings in event. So I'm right
okay.
now just like switching it over to an enum and like then doing
Yeah,
like a referenced one from like letting you
yeah.
register in the op tracker and then just like referencing it.
Yeah, I mean, if we can make those like const car pointers instead of actual strings in the case where they're fixed, that would definitely help.
Yeah.
Although it decreases the values somewhat. Because the problem is that when there's a stuck op, you want to know about it. And in order to know anything about the stuck op, you need to track this stuff. Um,
But the strings don't actually have to be stored as values in the event, right? I mean, it's just a name.
oh, yeah, hopefully not. Yeah, yeah, we can probably do better. So that's probably a ripe target to optimize. Um, yeah, it's such an easy thing to turn off, but it is pretty useful when things break. So
Yeah.
expected.
I think that will help a lot. It won't totally get rid of it. We still have a little bit of contention between like the messenger thread and or threads and
Yeah.
the TPO CTP threads. But
Hmm.
the big thing, the most obvious thing, is just the stupid
Yeah.
string
Yeah. All right. Well, let's
deletion.
see. Let's see how much that helps. How close I can get
Okay.
this. Okay, so there's that. There's another pull request from Igor that makes the cleanup deletion stuff in Blue Store faster. This one surprised me a little. He must have seen this where the OSD was just spending a lot of time deleting PGs after they get rebalanced or something. But it basically is a little bit more clever about prefetching when it's scanning, prefetching and pre-loading stuff into the cache so you don't go back and read it again later and so on. So it makes sense. But I haven't reviewed it yet. Take a closer look. A couple things merged, adding SSD and OSD, or SSD and HDD variants for the Recovery Max Active based on our discussion last week. That merged. I think the open question there is whether turning up just the Recovery Max Active can show the performance delta that you were seeing, Mark, or whether it is also necessary to have concurrent backfills.
It will help it'll help up to a certain level for like based on the number of OSDs you have. for when like an OSD is marked down. When you put an OSD back in, it will be based entirely on how many, if I understand Josh correctly, on how many threads that we have for the op work queue, right?
It's maybe.
Because we won't use more.
Yeah, that might be
so
true.
If it's like one, then we won't get any benefit from it.
Well, no, I mean there will, because you'll still have more data in flight over the network at once.
I don't.
Just if you're bottleneck. What's that?
Sorry, won't it? If you still have OSD max backfill set for 1, you won't get any more in-flight data over the network, will you?
Yeah, that's what this is. OSD recovery max active is the number of in-flight recovery writes, essentially messages at once. So if it's 1, then there's 1 message with like 4 megs or whatever going over the network. You wait until you get a reply and then you send the next one. If it's 100, you got literally 100 messages times 4 megs, so 400 megs in flight. Like the queue depth pipeline or whatever of the recovery.
And OSD max act. Okay.
That's what max active is.
Sorry. And OSD max backfills won't limit that?
Max backfills is basically how many PGs you're spreading it across.
Yeah.
So max backfills would be like we're backfilling 2 PGs, so they each have 50 in-flight operations as opposed to 1 PG with 100 in-flight operations. So the only real difference is that if you're bottlenecked on the source, like if you're backfilling to the SUME, or yeah, I guess it doesn't actually matter if you're bottlenecked on the read side, then having multiple backfills means that 2 OSDs might be reading and then writing to the same location. So it might go faster versus having 1 OSD reading and writing to the same location. But I think there are cases where increasing max backfills will speed it up, but most of the time, just increasing max active should be enough.
It didn't seem to work that way when I was testing it.
Okay.
It looked, the behavior seemed to be that we could get with max active bumped way up, you could have roughly like OSD divided by 2 active PGs being worked on in the cluster at the same time.
That's true.
That was with the OSD max backfill set to 1.
Right. That's what max backfill controls. Right.
Yep.
But that's the only thing that controls how many PGs are active.
Sure.
Yeah.
And of course, bumping up max backfill then lets you actually get up to OSD max active, or active, whatever the active one is. Recovery max active. Is that right? Active.
Recovery max active.
Whatever it is.
So I think the goal is to have the overall throughput of recovery. Mm-hmm. So max backfill controls how many PGs are recovering, but that's orthogonal to the throughput, or is mostly orthogonal. Right, so that we don't care about how many PGs are actually recovering. Like mm-hmm. We actually want that to be a smaller number so that they complete sooner. What we want is the recovery throughput to be as high as possible.
Yeah.
And so don't pay attention to the PG count, pay attention to the throughput.
What I think is important there though is that the PG count, if it's like half the number of OSDs, right, you don't have every single OSD in the cluster actually doing one at that point.
Yeah.
Right? Because you've probably like hit something where you're trying to do it on one that's already doing one and can't.
Yeah. Yep.
So that's the problem that we could maybe try to solve there, I guess, is figure out if there's some way to make it so that you can get even distribution without doubling up.
If the only reason you won't get every OSD participating is if they overlap, the PGs overlap, and so they would be competing on the same OSD, right?
Yeah.
And so, and the assumption is we want to avoid that because we want that OSD to be working on one PG and get it done as quickly as possible.
Exactly. But theoretically, isn't there something
2. The minimum is actually 2 because it's the primary role and the replica role. But anyway,
Sure.
we should repeat that experiment basically and crank up max active really high and see how high the recovery throughput goes. That's the thing we want to maximize. We don't care at all about the number of PGs. We want to maximize the throughput and see if it's
Well,
really necessary to increase max backfills in order to get higher throughput.
that test did kind of look at that, right? Like once increasing the OSD max backfills in addition to the active recovery did speed it up. It did make it faster.
It did.
Yeah.
Okay.
But this is also on NVMe, right? So you have inherent parallelism in the way that NVMe works.
So I guess the question is, should we add a HDD and SSD variant for OSD Mac backfills too? I mean, how high did you have to make it? Did you make it like 10 or did you make it 2?
I think I made it like 64 for recovery active, and then like 16 for max.
Yeah, we don't want that. We want it to be like 2 or 3 maybe, right?
Although having said that, those settings made it like a 70-30 split with like client to recovery IO. I know that's kind of high on the recovery IO side for what people want, but it was not nearly as like weighted towards recovery as you'd expect.
Yeah. Well, can you repeat the experiment with just backfill equal to 1, 2, and maybe 4, like just with small numbers? Yeah, I don't think we want to go higher than that. But if it's a significant improvement, or like 2 or 4, then maybe we should do that.
I think 4 would at least get you to the point where you'd have most OSDs participating in recovering 1 PG, right?
1 will do that. Setting it to 1 will have every OSD participating in.
It wasn't. It was half.
Well, it'll mean that no OSDs will participate in more than 2. So if in order to get every OSD participating in 1, then there are going to be some OSDs that are participating in 3 or 4 at the same time.
Yeah.
So those are becoming bottlenecks, right? That's why.
Sure.
And that's going to mean that those PGs. So probably what we really should do is do that experiment, but actually measure the start and end times of recovery for each PG. Sure. And then look at how much slower the recovery time for individual PGs are. Or actually even just look at the overall recovery time for the whole cluster, because maybe PGs take a little bit longer, but because they can start sooner, the overall recovery is sooner.
So Sage, my counter proposal is rather than doing all of this work and like trying to figure out optimal values for these that may not make sense based on how variable different NVMe drives are, let's just get the automatic, like trying to auto tune this based on client IO wall clock time. Let's do it that way. And then we don't have to try to like figure out stuff. We just have it tune itself.
Yeah, I mean, yeah, it's just an elusive goal. So, and doing something simple like setting max backfills to 2 on NVMe might be significantly better and a trivial change.
Yeah, that I'm okay with. It's just, at some point the testing starts becoming more work than the
right.
designing.
Yeah, I agree. Okay. All right. Well, maybe I'll add the SSD HDD thing then for max backfill and we can go from there.
Okay. Cool.
Okay. An RBD pull request journal performance that was merged, so that's good. There's a patch from Ma Zhengping that adds a new op create. This is basically a BlueStore related optimization that allows us to avoid some lookups in the cache when we know we're creating an object that doesn't exist. That's merged. There was one bug that fell out of that, but I think that's getting fixed now. So that should be good. And then your BlueStore cache refactor I did a build for that. I think I scheduled QA. I need to go look at that today. Adam's still working on some of the objector work. Let's see, the MDS cache tuning review. Roman had a messenger change. It was sort of a micro benchmark, so it's unclear whether that's have an effect on real workloads. So there's some discussion there, unclear whether it's worth proceeding with. And then your cache binning, which I guess is going to follow after that's going to be based on top of your cache refactor mark.
Yeah, we should also look at it once on top of the avoiding double caching PR, the 27705.
Right. Okay.
With some of those performance improvements, I want to make sure that this isn't slower now. But the sharding is.
Sounds good. Okay. Sounds good. So what should we talk about?
Let's see.
Maybe off tracker.
Anything else?
I have something, if you guys don't mind.
Yeah, go for it.
Sage, Mark and I talked about a little bit about performance testing at CephLocon, and we talked about trying to set up a sort of like a continuous benchmarking, performance benchmarking for Ceph for active development. So testing against things that are emerging in release branches, and set up like what defines an actual regression. And I think there's some machines available for these. It would involve some CBT work for sure, integration with, ideally integration with GitHub, so that we would be able to publish immediately results of like what the test is actually spitting out. I think it's very interesting work. It's going to take a little bit of effort though. Like, so I have I've been given some availability to start gathering all of the pieces so that we can put some design or objectives to get this going. Kifu sent me an email with a lot of interesting things that he wants to have for Crimson. He's especially interested. Well, Kifu and Radek are both like jumping up and down to have something like this. Because Crimson is specifically, trying to target performance. So in the next few days, I'm thinking no longer than next week, I'll put together this plan on what I think the next steps should be, and try to define the scope of the work, and start working on these.
That sounds awesome. How does this relate, or does it relate to the CBT tests that are part of the Rados suite now?
I don't know, Mark, do you know that?
So Sage, I think the idea would be that on for the stuff that Kifu and Radek want, it would be entirely through Jenkins doing basically just for builds, and then the stuff in Teuthology would be potentially even the same. It could be even the same tests that are run through CBT or a different set of tests. I mean, it doesn't matter, but it would be. The stuff that's in Teuthology would be kind of, Smithy, more just kind of, when we're running through tests there, we have some kind of thing that we can look at.
Okay. And then this would be like Jenkins workers directly on Inserta sample running some specific.
Yep.
Got it. Okay.
Yep. So then So this would be much more of we've got a dedicated set of nodes that just do this, and they're hopefully returning fairly consistent data. Whereas stuff that we run in Smithy and Tautology, I mean, who knows? The network could be busy. We don't,
Yeah, I especially like that way of setting things up, because we're trying our best to be consistent and same hardware over and over and over again, same specs, same everything.
Yeah.
So
yeah. And
my guess too would be that the stuff in Jenkins would be single like daemon tests, really focused on like the performance of a single OSD, whereas theoretically in Tautology we'd be doing multi-node tests.
Yeah. Or at least something that's simple enough that'll run on a single box. Maybe multiple OSDs, but one box. No network variation. So if this is through, so we're talking about doing this through Jenkins, and it's hooked into GitHub. All of the current plugins have like a one-liner basically that you can show up after the test name. Something like, currently it's things like all commits are signed, submodules are unmodified, blah, 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 makes check succeeded. I assume that we would want to make that something like, plus 10% or minus 30% or something like that. Is there like a baseline that we could use to have, what would that be? If it's just a number, then you're not going to know how that compares.
So I think that the statuses on reporting for GitHub can't be programmatically changed. They're like, it's like the job that says, what's the passing message? What's the failure message?
I see.
And you can't change them on the fly. But we do have access to the GitHub API, so we could set labels.
Or you can just comment. You could just add a comment.
Or we could just comment. Yep, absolutely. Maybe even better. Now, I think that I think that we just need to concentrate on getting the benchmarks working, and then see about the GitHub integration. And for sure, I'll bring it up so that we can discuss what you guys think is best.
Alfredo, I'm really hoping we can add attachments too. Like, I don't know if you can do that, but if you can like insert attachments into the comments with like
maybe
a bunch of like, just get wall clock profiles. We could have automatically generated wall clock profiles for every single like performance tag PR. That would be amazing.
Yeah, I mean, you can go into details and link to more stuff there. It doesn't have to be in a comment. But
these are all things that I had no idea about. So it'll take me a little bit to understand what the needs are and make sure that I'm following through with whatever you guys think is best. But I think, in any case, just wanted to bring this up and make sure you guys were aware. So I'll start digging into details and putting some plan together so that we can then review and see what fits, what works, what doesn't.
Yeah, if there are like a handful of, I don't know, 2, 3, 4 tests that run, or even just one, I could imagine that the comment would be like a little table that has the test name, and then with a delta to the latest master and the latest stable branch that you're based on. So it'd be like latest master, latest Nautilus, plus 10%, minus 2%, whatever it is.
So
that sort of that tells you. There's always going to be some variation, I guess, but you can.
There's that's an interesting thought, because Mark and I were discussing this, and I asked like what determines a regression? Is like a variation of 5% enough, or 10%, or 50%? Like what's the magical number we need here to like, and I think it's a hard question to answer, right?
Yeah, it depends on the variation in the tests.
Even if we can just
minus 10%, then it's all noise. But
even if we can just find gross things, right? I mean, that's like the first starting point.
Yeah,
like if something hurts some performance by like 40%, then we just knowing that is like huge.
Yeah, exactly.
I was thinking if we can do like different tests based on the tags. So if it's tagged as performance in RBD, we run some RBD tests. If it's tagged performance in RGW, we can do different tests, that kind of thing.
Yeah, that'd be pretty cool.
I don't know if that's hard to do or not, but it seems like that would be something that hopefully the like Jenkins GitHub integration stuff could do.
Yeah, I mean, or definitely bike shedding, but if you had both a baseline with the current master, like if you just keep track of what the latest master run was, and also the latest for each stable release branch, and you showed both, then also it'll just let you sort of keep a running tab on like how you're doing overall, because as the development cycle progresses, you'll see you're like plus or minus 1% on master and plus 20% on Nautilus or something. So that's nice to just have to see your progress over the course of this cycle. So cool.
Alfredo, I'm super excited about it. I think it will. There's a lot of really interesting stuff I think you'll be able to do.
Yeah. Yep. Agreed.
Yeah, I'm excited too. This is good. Happy to be able to help out here. For sure, Kifu and Radek were pretty adamant on having something like this, because I think right now they're kind of like in the dark, and yeah,
right.
Pretty happy.
Alfredo, Orlando expressed some interest in possibly also helping out, working on the like data parsing side and graphing and making nice pretty results from it. He's done some of that before, I think. Doesn't look like he's here today, but I might try to get you guys hooked together too, so that you can.
I did see an email coming through, so I'll dig that out. I'm buried in email right now, but I'll dig that out and reply all and follow up with him.
Cool. Yeah,
he doesn't work for us, right? Or he does?
No, he's from Intel.
Right.
Kind of the goal on that we kind of had for CBT output data was to have like a hash encoded directory structure for the output data, so that you'd be able to have that kind of be the unique key that defines then that's based on all of the parameters that were used to run the test. And then you could build some kind of index for it and have it, do some kind of query against your set of output directories that then gives you, whatever it is that you're searching for, 4K, random writes or something over the whole
That
data
sounds
set.
like a database, Mark.
Yes, we need it. The parameter space is too big to do anything else. So very much some kind of like database like query system for looking at result data. But not a big centralized database necessarily, since this is actually used like on the command line by people. So maybe more of an index.
We'll figure something out.
Cool.
So that's it. I don't have anything else. Just wanted to come in and mention this.
Awesome.
Yeah.
Okay. All right. Sounds great. Brett?
I've got a quick note. We did discuss this meeting with the MOC students and invited them to periodically drop in and maybe even present some of their stuff or ask questions. I mean, I know we are trying to be a little more engaged with them. I know Mark has been working with Aura, or at least talking to Aura a little bit, but it was just sort of there's been a lot of discussion with BU and Northeastern faculty. What's the right engagement model with the students? I think they're a little bit protective of them on one hand, and on the other hand, Matt and I were stressing if they're going to actually be doing things, and even if we take the code and ultimately get it merged, the right way to engage is with our upstream meetings. So that might be happening.
Awesome. Okay, that sounds great.
Cool. One thing I did want to mention is that Intel is ready to ship us the nodes for the new aficionados cluster. David gave them the shipping address and everything, so they've got everything they need. So they might
Awesome.
just be showing up at any random time here. I don't know what the status of the network is yet. I think we got hardware in, hopefully.
I think we have it all.
Okay.
That's my recollection. But
So
Yeah.
and that node configuration with just the swapping of TLC for QLC is probably what Intel's gonna recommend / provide for MOC for both RGW caching for the read-only S3 level caching that we're trying to get merged, as well as just straight RBD storage. Peter Desnoyers did some math, and he was convinced that the QLC is going to be as good as far as data retention and reliability as the high-capacity drives he's got. He almost convinced me. Wasn't quite sure of his math, but anyway, they're going to try that out. So it'd be I think pretty much the same configuration. I don't think they had the QLC ready for us. We're getting the TLC, right? Aren't we, Mark?
The new nodes, if I remember right, they're going to have the Optane drives for whatever we want to use them for, and then P4610s, I believe, getting
whatever those are.
See what the specs on them are. TLC.
Yeah, that's what I thought. Thought I knew that. Anyway,
before layer.
Kind of interesting.
And so if those come in soon, we're going to have a ton of work to do to get those set up. And then we've got some tests that Intel had shown a lot of interest in running. So some testing on those, and then start migrating the Inserta nodes into probably into Teuthology, just so that we can lock them and then assign them for Jenkins. And then Alfredo, those will probably at least somewhere between 4 to 6 of those will go to you for your stuff. Brett, you're muted.
Yeah, but I was asking a rhetorical question, I guess, probably. So those will be the constant nodes that we can use for performance regression. Does that make sense?
Yep, that would be the goal, is to migrate the Inserta nodes, probably 3 through 8 to those, because those 3 through 8 probably have had less wear on the NVMe drives. One's probably going to die soon, because that's the one I use a lot. But we'll keep maybe 1 or 2 of them just around for one-off testing, I think.
Yeah.
Maybe 6 of them for Jenkins. Alfredo, does that seem like it would be a reasonable amount to be able to use for it?
I don't think we'll know for sure the answer until we're basically doing the work. I guess it's good to start with.
Intel also expressed
play
a lot
by
of
ear,
interest.
I guess.
Intel also expressed a lot of interest in having some of the aficionados nodes potentially participate in PR testing. So you may get a couple of those as well. We have 10 of them, which we'll have to figure out the right way to divide them up, but we may at least be able to get you a couple of those. maybe we use those for really specialized high performance testing. Like if there's something that we see or that we expect to only really show performance gains on really high throughput setups or something. All right. Well, I think that's about it. Anyone have anything else that they want to bring up?
Nope.
All right. Well, have a good week, everybody.
Yeah.
Yeah.